This is 7.4 through 7.6 review, starting in the textbook and then in the review packet for 7.5, 7.6. So starting with number 5, a computer's memory is measured in terms of megabytes, and we are going to look at how the megabytes have increased since 1977. So year 0 would be 1977, and every year after 1977, we're going to be adding 1. All right, so what we're going to do is we're going to plug this into the calculator and then use exponential regression to come up with an equation, and then we're going to plug a number in that represents 2020 into that equation and be able to predict how many megabytes or what's the size of the megabytes or the amount of the megabytes that computers have in 2020, which just so happens to be this year. So first of all, we are going to go to stat and then you hit edit. I've already got these input. Wrong calculator. I've already got these input just for the sake of time. You don't need to see me click all these in. So once you have these listed in L1, L2, remember you should always see these side by side. You're going to go to your y equals and make sure your plot's on. If you have anything in terms of equations in your y equals, you're going to want to get rid of those. And we're going to want to adjust our window so we can see it. And students a lot of times have trouble figuring out what do I put in my window when I'm not given a window. So we just have to fit these values. We have to go from 0 to 27. So you can even make that your minimum and maximum, 0 and 27. If you're going from 0 to 27, you could count by 1s or 2s. Your y minimum, I'm just going to put 0. Maximum of 512. And I don't need to see 512 tick marks. So I'm going to have this count by 50. And we're going to go ahead and graph this. And you can see, now, let's say you had left the scale for y on 1, right? Or the x on 1. These are going to just create a lot of tick marks, but you're still going to see all of your data. You also notice how this last piece of data is kind of almost off the graph. And that's because we chose our maximums to be the exact numbers. It helps if you make your maximums a little bit bigger than what you need, and then you'll clearly see that last point. Okay, but the important part is we see that this is exponential. Okay, so the whole reason that we look at the graph is so that when we do regression, we need to know, is it linear regression or is it exponential? So now that we see that it's exponential, you're going to hit stat, move over to calculate, and you're going to go down to exponential, which is number 0, exponential regression. Go all the way down to calculate. And it's going to run this for you. Now, to get the answer that matches the book, we're going to have to go 3 spots, but you can go 4. That's what we've been doing traditionally. So it's 1.20, and they left it right here and rounded it, so the 1 became a 2 because of the 9, times 1.295 raised to the x. Okay, now that's not the answer to this. It specifically is just asking for how many megabytes are there going to be in 2020. So we need to plug in a number for x that represents 2020. So we need to know how many years 2020 is after 1977. So the easiest way to do that is just take 2020 and minus 1977, and you're going to get 43. And so that's how many years it's been since 1977. So we're going to go ahead and plug that in. So we're going to put our equation 1.202 times 1.295, and we're going to raise that now to the 43rd. And that gives us our answer of about 80,817. If you put some decimals, that's fine. We're not really sitting here going to, fight over decimals and stuff like that. Okay, we're much more worried about the big process that we're looking at. All right, so moving on to number 10. So in number 10, we're looking at this chart, 10A. They want us to make the scatter plot, and we're going to give it a quick sketch. And we've got 3 different columns here, so we have to figure out which ones are we going to put in. So they tell you to calculate it with Y being the gross sales and X being the weeks. So we're going to ignore the rank that the movie was, okay? And we're going to determine, is the exponential model a better one or is the linear one better? And again, I've already gone to stat, edit, and I've put all of these in. You'll notice these little E's is just because those numbers are so big they can't fit in this little screen, but when you highlight them, you can see the full number. So they're there. Okay, there's just not enough space in the L2 little cell right there to show it. So the E is just telling you that there's more going on there. All right, so we're going to go ahead and have to adjust our window. Minimum to maximum. Like I talked about in the last one, we want to go a little bit off of this so we can see it. So I'm going to do -1, and then just a little bit bigger is 12. Okay, my X minimum, I'm going to change this. It needs to be less than 403,000, so I'm going to go to 400,000. And my maximum has to be bigger than this. This is 114 million, so I'm going to go to 115 million. And I'm going to have it, that's a lot of millions there, so I'm going to have it count by at least 1 million. In fact, I'm going to have it count by 10 million. And there we go. So when I graph it, I can see this is going to be decay, but it is exponential, right? Because it's swooping down. And so the exponential model would be better here. Part B, we're going to go ahead and use regression. So you're going to hit stat, calculate, number 0, and you're going to run this through. And for this first one, I'm going to go ahead and use that whole number. Don't necessarily need the 0.6 at the end, but I'm going to use the rest of it for sure. So that's 118 million times 0.618. I'll stop there, raised to the x. Again, you may all shorten things up. As long as you're showing your work, I can see what you're doing, you're fine. You don't have to go the same number in terms of your rounding every single time. Okay, we've talked about the farther you go out, the better. But at a certain point, going all the way out to that is just tedious. Okay, so part C now, we're going to run this. What are the gross sales on the 20th week? So we're going to take this equation and we're going to plug in 20. And our predicted sales are $7,856.50. Okay, so number 11. We've got this trial going on. This is our chart. We're going to input that in. Okay, we're going to hit stat and edit. I've already got this input into here. So we're going to go ahead and look at our scatter plot. But first, let's change our window so it makes sense. We're going to go from 0 to 10, basically. Counting by ones would be fine there. And we got to go from 2 to 60. So I'm going to go from 0 to 65. And I'm going to count by tens. And let's make sure my plot is on. So if I hit graph and I don't see anything, what you want to go do is hit y equals and make sure your plot's turned on. Hit enter. Okay, it's highlighted. And graph it. Boom, there it is. So clearly, this is curving up. This is exponential. So that's part A. Create the scatter plot. Part B, now use exponential regression to come up with an equation. So we're going to hit stat, calculate. It's exponential, which is number 0, which you can hit 0 or scroll down. Calculate. And we'll just shorten this up. 1.57 times 1.49 raised to the x. And that is all they're asking for. They didn't give you any information to plug in and predict anything in the future. Okay, but this is the equation you would plug into. That's all they're asking for. Okay, moving over to the review packet. 7.5, we're going to talk about a lot of domain and range and functions. So, number 1, you have your function f consisting of only these ordered pairs. If this was on a graph, these would just be points and they're not connected. What is the domain of f? Domain are the possible x values. Okay, so my possible x values here I just have to list them. I'm not going to write it as an inequality because they are not connected. Everything in between is not part of the function. The function f is just these ordered pairs, these points. So my domain is my list of x values, so -2, -1, 5, 6, and 8. And my range are my y values, so 5, 2. You don't have to list 2 again. 7, and 25. And you'll see the answer key lists those in order from least to greatest, which is nice to do, but you don't have to. Number 2, multiple choice. Which one of these is not a function? So it is not a function if any x value has more than one y value associated with it. So when you look here, each one of these x values are different, and they all have a y value. Now you have a repeated y value, okay, but that's not what distinguishes a function from something that's not a function. If I asked you what is the y value when x is 0, you can tell me it's 2 definitively. Okay, no problem there. If I asked you what's the y value when x is -1, you can tell me it's also 2 definitively. Here's where there's a problem. If you slide over to letter B, if I ask you what is the y value when x is -1, you have to tell me it's 2 or 3. Okay, and that makes it not a function. An x value cannot have more than one y value associated with it. So which one does not describe a function? Is letter B. Okay, down here on number 3, we're going to find the value of the function when x equals 5. This is your x value here, so you're going to slide over to x equals 5 and follow it up. That's 200. Find the value of the function when x equals 3.5. That would be right between 3 and 4. It's going to hit there at 150. Now find x. So we're going to be finding it's going to be 0, 1, 2, 3, 4, 5, 6. It's going to be one of those when the function is $50. So here's 50 and slide over. That's at x equals 1. And then use inequalities to describe the domain and range of this function. We have to use an inequality because it's not just points, it's everything in between. So everything greater than, less than, all of that. So starting with domain, that's going to be related to x. What is it greater than? What is it less than? My x values stretch from 0 to 6. Everything in between is included. There are no gaps that I have to show. So everything from 0 to 6. X is greater than or equal to 0, but also less than or equal to 6. Range expressed in terms of y. My y value also goes from 0. And it is continuous. It does not disconnect all the way up to 225. Number 4, looking at this graph, determine the domain of the function. So all the possible x values that this graph or this function will hit. So because there's arrows here, that means it does not end, it continues. This is not the end of it. So if there was an end point, then my x values would end right here. But this goes on forever, and it's going up, but it's also moving to the right. And so we will continue to move both up and to the right forever. And so it will hit every x value past 8. It'll just keep going. And same thing this direction. It's going to go past the -2, and it's going to get -3 and 4 and all the way to -10 and on forever. So there isn't a single x value that this will ever miss. It's going to hit everything. It hits 0, all the negatives, all the positives. So what are the possible x values of this function? It's every real number. For letter B, the range, it will go on forever this way. So all of these positive numbers up here are part of the range, but there are no negative numbers in this function. Okay, in fact, 0 is not a part of this function either. It stops at 1. 1 is the lowest number that's part of this function in terms of your y's. And so y is everything that is greater than or equal to 1. From 1 up, all of those y values are part of this function. Letter C now, a little more specific. Give the range that corresponds to the domain of x less than 2. So here's where x is 2. I'm going to draw a line down. They want me to give the range that corresponds to when x is less than 2. Less than 2 is this way. These are all the values of x that are less than 2. So basically, we are not looking at anything over here. We're not looking at that. So we're just looking at the function itself when x is less than 2. So it's from here all the way up. And it will go on forever. So everywhere where x is less than 2, this y value is going to continue up. But the lowest it's going to get when x is less than 2 is right here at 3. So the y value is going to be from 3 up, and we can't say that it includes it because it doesn't say when x is less than or equal to 2. It just says less than. So this actual point on x equals 2 is not included, okay, but it's everything going this way, which is everything greater than 3. Okay, number 5. So we're going to go ahead and graph this. Easiest way to do that is just grab your calculator. You're going to go to your y equals. If your plot's on, you're going to want to turn that off. We don't want to see all those points from L1 and L2. We're going to go ahead and plug in this equation. So x squared minus 2. I'm going to go to graph. I probably have a goofy window going on if we're working on something else. Easiest way to fix that is hit zoom and number 6, zoom standard. Gets you back to your basic -10, +10 minimum maximums. Okay, now this sketch doesn't have to be perfect, but this point right here is going to be important if we're talking about range. Okay, all of these where they hit exactly, not necessarily important for what we're talking about right now. So we do need to make sure this is counting by ones, and so this is going to hit right here at -2. Okay, and then it's going to go up, and you can put the arrows. This will go on forever. This isn't the only part. If I zoomed out, this is going to keep going. But it's important that I have that part right at least. So what's the domain of the function? Much like the one up above it, this is going to go on forever, and it will continue to move to the right, and it will continue to move to the left. It's not going to miss any x values. So every x value is part of the domain, so all real numbers. The range will continue to hit every positive number, but the lowest it's going to get is -2. There is not any value on this function that hits -3 on the y's. -2 is the lowest. So expressing the range in terms of y is going to be greater than or equal to -2, and I can't put a cap on it because it will go on forever into the positive. So every number that's greater than -2 is a possible y value. All right, number 6, this function is graphed over here. Okay, true or false? 0 is in the range of this function. So range is your y values. So this function right here will never actually hit 0. It's going to continue here forever, and it's going to stay really, really close to it. You can see this is decay, right? So it is coming down. Well, actually, this is growth, but with a negative number. Okay, but it's still the same shape. We know about that. It's going to get really close, infinitely close to that, but it's not actually going to hit it. So 0 is not in the range of this. So that's false. What's the value of this function when x is 0? So find where x is 0 and go down. What's the y value? -2. So whenever they say what's the value of the function, they're talking about the y value. When x is 0, y is 2. Okay, what's the domain of the function that is graphed? Okay, this is going to go on forever this way. So all of these negative x values will be a part of it. It's actually going to keep going this way too. It's going to creep slowly, but it will go on infinitely and hit every x value. And so this is all real numbers. Every x value will be hit. And then it says suppose x can be any negative. So x, we're talking about any negative number or 0, but that's it. So no positives. So we're not looking at any part of the function in the positives. X can only be a negative number or 0. So in that case, what is the least possible value of y? So this is getting bigger and bigger and bigger. It'll never hit 0, but it is getting small. Like it's getting closer and closer to 0. So it is getting bigger in a very small fashion, but it's never going to come back down. So the lowest point that we're going to see, or the least possible value of y that we're going to see, is right here at 0, which is included, which is -2. All right, and the last page, 7.6, we crossed out letter C. You can actually cross out letter D as well. I'm not concerned about that. Number 1, suppose a function consists of only these ordered pairs. What's the domain? You're going to list them off. So x values, 0, 1, 2, 3, 4, and 5. The range, y values, 1, -2, 4, -8, 16, -32. The book puts them in order. I'm okay if they're not. All right, consider this. Find j of 2. So notice 2 went in place of x when naming the function. And so this is the actual expression that represents the function. And so we're going to go ahead and put 2 in for x in the function. So it's -5 times 2 plus 2. That's -10 plus 2, or -8. You're also going to plug in negative 3.2, and run it. That comes out to 18. True or false, j of 4 is less than j of 5, so we have to find those first. So first thing we're going to do is j of 4. So it's negative 20 plus 2, that's negative 18. J of 5, negative 25 plus 2 is negative 23. So they're asking you, is this true? Is negative 18 less than that? That would be false. Negative 18 is bigger than negative 23. Number 3, if g of x equals this, find g of negative 3.3. So we're plugging that in. So it's 2 times 1.3 raised to the negative 3.3. And it says to the nearest hundredth, that's 2 decimal places. So 0.84. Number 4, we've got the function L of x. We're plugging in 4 for x, so negative 2 times 4 minus 3. That's negative 8 minus 3, which is negative 11. Plug in 2, negative 2 times 2 minus 3. That's negative 4 minus 3, which is negative 7. And then letter C, we're going to evaluate this big expression here, but we already have L of 4. L of 4 is negative 11, so I'm going to replace this with negative 11. I'm going to replace L2 with negative 7, because that's what they're equal to. So negative 11 minus negative 7 over 4 minus 2. This goes plus plus, so it's going to be negative 4 on top. 4 minus 2 is 2. Divide, and that's negative 2. And number 5, the table below shows the centimeters of rainfall in a given town. Here's your x, and then these are your centimeters of rainfall. X is the number of months. So what's the value of R of 2? So thinking back up here, when it said L of 2, that was going in for x. So we're putting 2 in for x and finding the value. So the value there is 4. On what day did they have 10 centimeters of rainfall? This is your centimeters of rainfall, so that is day 4. And then this one, okay, tough question right here. Find x if R of x equals 2. Okay, a lot of people will say 4 again, but it's not asking the same thing. It's asking you to find what should be inside the parentheses. What should be the x when the answer is 2? So R of x equals 2 right here. So what's x? X equals 1. If I asked you to find R of 1, you would come up here, find x, and the answer is 2. And so if you look, we're trying to find x when R of x equals 2. When R of x equals 2, x is 1.